So for my laboratory number 2, for about building network topology and design, and we will use Cisco Packet Tracer for uh, simulating the network system in this activity. So in this activity, the procedure is open the Cisco Packet Tracer program into simulation mode. Number 2, single click on the end device and single click the generic host. Number 3, choose PC and move it by dragging the cursor in the topology area, just like the picture shown below in the diagram. Number 2, add 3 more hosts as shown below. Here, the procedure is we need to connect PCO1 and PC1 to a switch 01 and PC2 and 3 to switch 1. So we can use any switch model, but for this experiment, the sample switches selects 2950-24 and then add the switch by moving the plus sign below in PCO and PCO1. Then connect PC0 and PC1 by first choosing connections. So click the copper straight through cable, then configure PCO by clicking it once. Choose pass internet and drag the cursor to switch 0 just as show below. So click on number 8, click on switch 0, choose pass ethernet 0/1 as shown below. And then we notice a green light on PCO ethernet and an amber light switch 0 pass internet 0-1 or 0/1 port. So it means that it is temporary, not forwarding frames. So we will wait for 30 seconds and the amber light will change to green, indicating that the port has entered the forwarding stage. Then repeat steps 5 to 9, but this time we use another PC example, the 2 and 3 to another switch. So this is actual switch port, does not matter. So let's do the laboratory. We are here in Cisco Packet Tracer to do the same simulation in laboratory number 002. So first, we need to enter in simulation mode. Then the problem is we need to get for end device, which is the PC. So PC0, PC1, then PC2 and PC3. And we need to drag 2 switches here in network devices, then select switches, and then we will use the 2950-24 for the PC0 and PC1, and another switch 2950-24 for PC2 and PC3. Then next, let us use for the cable the copper straight through, and let us connect the PC0 and PC1 to our switches. So here, select pass Ethernet, then pass Ethernet 01. Then next is PC1 to pass Ethernet to 02. So as you can see, there's green light here and amber yellow in the switches. So let's wait for 30 seconds to let's wait for 30 seconds and let's see if the amber light will change to green, indicated that the port has entered the forwarding stage. So let's run the simulation. So as you can see, the amber light turn into green. So the forward stage, the forwarding stage is successful. Let's do it in another example, which is PC2 and PC3. So let us connect and select the copper straight through cable from our switches to PC2. Then select pass Ethernet. Then another one, pass Ethernet 02 to PC3. So let's wait for 30 seconds to turn the amber light into green. And let us see if it is a successful forwarding stage. As you can see in our another example, in our, the forwarding stage is also successful. So for our next laboratory problem, so using as the step 1 to 10, construct the following topologies using 5 PCs, 3 laptops, and 1 printer, at least 2 switches or hubs, for the example. It depends on your design. There should be green light indicating the frames are already forwarded. So let us make, number 1, the different kind of topologies in networking. Number 1 is bus topology. Number 2 is star topology. Number 3 is ring topology. Letter D is mesh topology. And number 5 is hybrid topology. So first, we need to do this bus topology. We are here now again in our Cisco packet tracer to do the example of a bus topology connection. So in our problem, we need to drag 5 PC, 3 laptops, and 1 printer. Total of 9 end device and at least 2 switches or hub. So 5 PC, 3 laptops, and 1 printer. 1, 2, 3, 4, 5. 3 laptops, 1, 2, 3, and then 1 printer. 1 printer. Then switches or hubs. So this time I will use the switches. So the same as the previous example, I will use 2950-24 for the switches. So I will put 8 switches in this example. 2, 3, 4, 5, 6, 7, 8. So let's connect our switches with a media. I will use the media connection copper crossover for the connection of the switches. So pass Ethernet 01 to pass Ethernet 01. Then pass Ethernet 02 to pass Ethernet 01, then pass Ethernet 02 to pass Ethernet 01, again, so on and so forth. Then let's connect our end devices in our switches. As you can see, the forwarding of the switches, the connection of the switches are successful. It turns the amber light or amber yellow in green. So let us connect our end devices with straightforward or copper straight through media connection. Then let's choose 02 for our switches, so on and so forth. Okay, so as you can see the first 5 samples, the PC 1 to 5 is now all green. It means the forwarding connection or the forwarding that all frames are already the forwarding stage are successful. So now it's all green. Our bus topology connection is the forwarding stages are successful. Now let's try to build a star topology network in our Cisco packet tracer. So we need to build star topology by putting 5 PC, 1, 2, 3, 4, 5, 3 laptops, 5 PC, 3 laptops, and 1 printer. 5 PC, 3 laptops, 1, 2, 3, and 1 printer. Okay, and let's use routers for this connection. Let's use the 1841 router. For this connection. So let us use for the cable, the copper straight through cable. So pass Ethernet, okay, pass Ethernet 001, pass Ethernet 01, then So for our network devices, let's change it with switches. Again, the 2950-24. And then for the cable, we need or network cable, we use the straight copper straight. So fast Ethernet connection 01, fast Ethernet 2, fast Ethernet 3, then fast Ethernet 4, then fast Ethernet 5, fast Ethernet 6, fast Ethernet 7, then fast Ethernet 8, then fast Ethernet. Okay? As you can see, in our first 6 end devices, all the forwarding in our forwarding frames is, or forwarding stages are successful. Let's wait in the last end devices if it is all successful. So let's wait for the 2 end devices if it is successful. Example is the ring topology. So let's use our end devices, the 5 PCs, 3 laptops, and 1 printer to do our this ring topology. So for our network or network cable, we will use the copper crossover and the copper straight through cable. So first, we need to indicate, or we need to drag our network devices. So I will choose again the 2950-24 switches, 246. Let's put two switches. So 2, 1, 2, 3. Then let's connect the 3 switches with the copper crossover cable. So 1, 2, and 2. Then let's put our 5 PC, 3 laptops, and 1 printer. So let's put the 1, 2, 3, 4, 5. Then let's put laptop here. So 1 user use laptop here, and 1 user use laptop here. And for the printer, 1 user use laptop here. So let's connect our end devices to our connection of switches. So we will use the copper straight through cable, fast Ethernet, then Pass Ethernet. Pass Ethernet. Okay. Then the next group. Pass Ethernet. Okay. So this is our connection called the ring topology. As you can see, one by one, our forwarding stages is turn amber light in green light, and it means the forwarding stages is successful. Okay. Only one. You in simulation mode. Simulation, then run the simulation. Now we are doing the mesh topology. Let's go back to our Cisco packet tracer. So I want to put 2960 for our switch. I will put 4 switches. Then for our end device, 5 PCs. Okay. 3 laptops. Here. And 3 laptops and 1 printer. So let's connect our 3 switches with our copper crossover. I will use copper crossover to connect all our switches. Then let's connect this with this and this with this. Oh, I forgot to view us in simulation mode. Then let's connect our end devices in the switches, and let's use copper straight through. Okay, pass Ethernet. This one. Okay. Next this one. Okay, on is connecting. So this is our mesh topology. Connections in our network. So for our last topology, we will do the hybrid topology, and I will select the pass topology with the hybrid topology is the combination of different topology in our network. So in this laboratory, I will combine the bus topology and the ring topology for our hybrid topology. So let's go in our Cisco packet tracer. So let's put our switches. I will use again the 2950-24 for our switches. 1, 2, 3, 4. Then 1, 2 for our bus. So let's connect our switches with copper crossover. Here. Here. Then for our bus, this is the ring topology. Okay. Then for our end devices, which is the 5 PC, 3 laptops, and 1 printer. 5 PC, 1, 2, 3, 4, 5, and 3 laptops. 1, 2, 3, and 1 printer. Let's put the printer here. Okay. Let's connect our end devices in our unit. We will use the copper straight through in our end devices through the switches. Okay. 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 This is my example of my hybrid topology, which is the combination of bus topology and ring topology. On our last part, in our last part of the activities, which is the question and answer portion, this is to be answered within the video. We will define the people. We will define and answer the different kind of questions. So for question number 1, what does amber and green light indicates in Cisco packet tracer. So for my answer, a switch in working operation is denoted by the color green, whereas an amber color indicates that there is a problematic connection within the switches, which means the switch isn't connect correctly in the connections. So when the LED light is off, this is an indication that the user needs to check if the switch is connected to a power source directly. Number two, what is the function of the switch and hubs? So this is different type of, the switch and the hub is different type of network connection. So a hub is a switch to use connect various network segments. So a network which is a small hardware device that joins multiple computers together in one local area network or LAN. This is called, we will use the switch. For the hubs, a hub connects multiple Ethernet devices together, making them act as a single segment. Question number 3. What do you think is the topology that only uses a single medium? So for that, for the answer, it is the bus topology. So why bus topology? Because in bus topology, a network type in which every computer and network devices is connected in a single cable. So when it is exactly 2 endpoints, then it is called linear bus topology. So that is the answer for number 3. So for our conclusion, number 4, what can you conclude from this activity? In my conclusion about this, in using for laboratory number 002, I therefore conclude that in CSCO packet tracing for Lab002, we do this activity to familiarize the different topologies like the bus topology, star topology, ring topology, mesh topology, and hybrid topology, which is the combination of our different kind of topology. And then for the construction of a simple connection that could simulate transferring of messages using the CSCO packet tracer, which is the indication of green light indicating that our forwarding stage is successful or not, and the indication of the amber light will which is the connection is a failure. Then for last conclusion, this design network topology is depending on, we will use the different kind of topology depending on our needs or our depending on the application of our network. Thank you.